This one here involves natural logarithms. See if you can prove that the left-hand side equals the right-hand side. Okay, try it first. The foundation of the natural logarithm is built on the concept where we have, let's say for example, I've given y equals 2 to the power of x. This would be an exponential function that goes up like that, y equals 2 to the power of x, and going through the number 1. Now, the natural logarithm is a very special number e, where if we have y equals e to the power of x, it looks exactly the same. The only difference, e is this very special number, and that number is like pi. So it has a specific value, which is a constant, which is actually equal to the following. So e is given by the value like pi 2.7182, etc. And it's a standard number, it's fixed. So this can be rewritten as y equals 2.7182 to the power of x specifically. Y equals 2.72, let's say, or 2.71, etc. to the power of x. Also going through the number 1, very close to this, but not exactly the same. And this specific number is very special because once you find the gradient of this number, you realize that the gradient is equal to, so when you derive this function, it is itself. So that's the long story after that of why it's so special as well when you're doing derivatives. When it comes to logs and log rules around natural logarithms, it's very similar to normal logarithms. You'll also find this on your calculator. You look for ln, and you'll see ln is right next to the log button, maybe around there somewhere. So the properties of natural logarithms are as follows. Let's put them on this side over here. So natural logarithms properties. The first thing is if we've got ln or log AB, it will equal log A plus log B. But specifically for the natural logarithm, we use ln instead of log, which is log. But if you've got ln A divided by B, it'll be ln A minus ln B. If you've got, or log, I'm just using the word ln just so you can see the difference, but it's actually log. Ln m to the power of p, p goes to the front, becomes p log m. E to the power of log x will equal x, and log or ln e to the power of x is also equal to x as well. And these properties are proved separately. E to the power of x is equal to e to the power of y, then therefore x equals y, and ln x equals ln y, therefore means that x equals y as well. Okay, so just keeping all of those properties on the left hand side for now. Can I use any of them for this? Let's see. Treating it as a log, looking at the left hand side, I can change this into 4 squared, right? So I can write this as 4 minus ln 4 squared, and I can then take the power to the front, making it 4 minus 2 ln 4. I could also change this into base 2, and maybe that will be even better. Because if I change it into base 2, right, then it'll become 2 to the power of 4, and then I can factorize that out. So 4 ln base 2 to the 4, bringing 4 to the front, would be better. Taking out 4 as a common denominator, and then leaving that as that. 1 minus ln 2, which is a value. Over here, I've got the division rule, which is that part over there. And I got 4 multiplied by what is ln e minus ln 2. Now, ln e to the power of x is x. So if this is power 1, then that number equals 1. So that will equal 1. So ln e equals 1. So this will be 4, 1 minus ln 2. And so we're done. Right, those two are equal. So the left-hand side equals the right-hand side. And this is just part of the fundamentals of the natural logarithms.